Yeah, let's just take a quick look at Kubernetes. How does Kubernetes work, right? When we say we want a container to run, this is a simplified view, right? Just to keep in mind here, nothing communicates with etcd directly, right? Everything communicates with the Kubernetes API, but we're just showing some dotted lines here to show logical flows. And we have the requests go in, Kubernetes API receives it, it tells, or it writes an etcd that there's a, a pod desired or deployment desired, right? And then kubescheduler picks it up and sees, okay, there's some new pods that need to be deployed, haven't been scheduled yet, writes in, or tells etcd, here's the nodes where these pods should be scheduled, and then kubelet picks up on it, sees that it is scheduled to deploy some pod, and then it goes ahead and deploys some pod. And then there's various controllers in the system: pod controller, replication control, replica set controller, or replication controller, excuse me, and other controllers as well that watch various aspects of things, deployment controller, etc. And those are always checking to see if the state. So kubelet is always reporting the actual state of the workload back up. And if anything changes, then the respective controller, whether it's replica controller, pod controller, etc., will take the prescribed action based on what happens. So it could be restarting the pod, it could be rescheduling the pod on a different node, providing some sort of metric or alert. And that's a little nutshell there of how it works. But what would happen if we took those VMs and kubelets and said that they're ESXi hosts and spherelets? I mean, we need to have necessarily anything different? And really the answer is no, right? There are some little differences because this is not a standard Linux host with a standard kubelet on it. But the spherelet actually natively understands the kubelet commands, right? And it also expands upon that with additional custom types that allow us to represent really the scope of different services and resources that are available in our vSphere environment, but into a Kubernetes language. And so what does that mean? It just means that you think about a pod is an object type. So I have in my etcd database, I keep a certain amount of metadata, and that is essentially the definition of my pod. And so I can create a custom resource, and I can say, well, maybe instead of a pod, I want something called a VM, and it'll have this metadata associated with it. And then I need something like the spherelet that can report back that information. Oh, look, or understand it, right? Oh, I see I'm scheduled to deploy a VM. I can do that. I can report back information about the state of the VM. If we add that information about the what we want it to track, what we want it to know, what we want to define about the object that we're trying to add or the resource that we're trying to add. So Kubernetes has a whole framework for that. With custom resources, and so we can put that information in the system, and next thing you know, we're able to deploy different types of objects as well. So if you want to deploy a virtual machine, right, if we create the custom resources and we create the appropriate controllers, and of course having the spherelet aware of how to run that type of object, then we no problem. Kubernetes works very well for that, and it works, and so the idea that you have a different type of node here that can understand and implement these systems, it's pretty straightforward, right? And let's go ahead and see now. If I can play a VM, then I should be able to play multiple VMs, right? And so why not be able to deploy control plane and node VMs for a Tanzu Kubernetes cluster? And so here, I mean, that's exactly how it works. Kubernetes, if you tell it how to, it can watch and deploy and manage virtual machines the same way it can with pods, right? And once you have those virtual machines deployed, it runs standard Kubernetes on top of it. And so if you provision a cluster like this for users, they're able to have full control. Maybe you could say provision a cluster like this for a development team, and maybe that development team has a DevOps a person or an AppOps person who's kind of in charge of their team's Kubernetes environment, and maybe they have different developers. And so when the IT operations can give this type of abstraction, abstracted Kubernetes implementation, we still have Kubernetes running in our core vSphere environment, yes, right. But for developer environments where we want it to that group to have the ability to have control and self-service, right? This provides an additional abstraction that makes that very safe and very sustainable.